AI has made incredible strides in a short time, but the latest developments signal even bigger changes ahead. While models like OpenAI's GPT-3 have been built on transformer architecture, OpenAI CEO Sam Altman recently hinted that transformers might soon be replaced by entirely new AI models. This shift could redefine the future of AI, pushing beyond current limitations. Let's dive into how AI is evolving and what's next for the industry. A new era for AI architecture. Sam Altman's bold prediction that transformers may soon be replaced by new AI architectures has sparked a lot of buzz in the tech world. Transformers have been the backbone of models like OpenAI's GPT, driving advancements in natural language processing and revolutionizing industries. However, there are significant limitations that come with scaling transformer models. As the amount of data increases, the computational resources required to process that data grow exponentially. What this means is that the cost of scaling becomes unsustainable. Just making data 10 times longer can lead to a 100-fold increase in computation costs. Altman believes that the next leap in AI could follow a similar trajectory to what happened when AI shifted from older models like long short-term memory networks to transformers. He suggests that current AI models may be smart enough to discover the next breakthrough architecture, creating a feedback loop between AI and human researchers. This collaboration could lead to faster advancements and allow the field of AI to move from slow, linear improvements to more rapid, transformative shifts. With AI playing a part in its own development, the future of artificial intelligence could unfold at an unprecedented pace, enabling innovations we can't yet fully imagine. Apple's leap into 3D object reconstruction. In another groundbreaking move, Apple has introduced Leto, a model that pushes the boundaries of computer vision and 3D reconstruction. Leto can take a single image of an object and reconstruct it into a fully realistic 3D model, complete with accurate lighting, reflections, and shadows. This addresses a major limitation of previous systems. When an object was viewed from different angles, older models couldn't maintain consistent lighting, which led to a noticeable break in the illusion of reality. What makes Leto so advanced is its ability to compress thousands of object views into a compact internal representation. Instead of relying on a massive amount of data at once, the model learns a summarized version of the object, which it can then use to reconstruct the full 3D model. The result is a system that can create a 3D object that stays consistent and visually accurate no matter the angle from which it's viewed. This leap in technology exemplifies how AI is moving beyond traditional image recognition to truly understanding and replicating real-world physical structures, setting the stage for more immersive, virtual experiences. Advancing spatial understanding with AI. Inspio World FM is another innovation pushing the envelope in AI's understanding of the physical world. Unlike traditional AI models, which are typically focused on images or objects, Inspio aims to give AI a deeper understanding of 3D space itself. One of the challenges with AI-generated videos and virtual environments has always been inconsistencies, objects that move erratically, scenes that don't hold up under different perspectives, and a lack of coherence in multidimensional spaces. Inspio's system focuses on multi-view consistency, which ensures that objects and scenes maintain stability and coherence even when viewed from different angles or as they change over time. This technology represents a leap toward AI systems that can truly understand space, not just create static images or videos. What makes this model even more impressive is its ability to run in real time on consumer-grade GPUs, such as the RTX 490, which would allow these capabilities to move from research labs into real-world applications much faster. This shift in spatial intelligence is crucial for applications like robotics and augmented reality. In robotics, for example, if a robot loses track of its environment, its ability to function is severely impaired. By incorporating explicit anchors, points in sign, and implicit memory CERN pattern, Inspio ensures that its AI can remember its environment even when the viewpoint shifts. This enables AI to maintain continuity and stability, which is essential for systems like AR, where spatial accuracy is key to creating seamless experiences. With real-time spatial understanding, the potential applications for AI become even more diverse, from enhancing virtual worlds to improving the navigation and interaction of autonomous robots in dynamic environments. The rise of AI agents. In an exciting shift, AI is moving beyond simple chat-based interactions and evolving into actionable task executors. A notable example is Manus's My Computer model, which allows AI to directly interact with your personal computer. Unlike traditional AI systems that operate in cloud-based environments or limited sandboxes, My Computer can read and manage files, run commands, and even access local resources such as your GPU. This represents a significant advancement in the way AI is applied. Rather than acting solely as a passive assistant, AI is becoming an active agent, capable of organizing files, automating tasks, and controlling applications all on your local machine. One of the key features of this model is the built-in permission controls, ensuring users have full oversight of what the AI can access and interact with. This ensures a balance of power between automation and user control. The implications are vast. We're moving towards a future where AI is no longer just a tool you ask questions to, it's becoming a partner that works alongside you to get things done. Whether it's streamlining workflows or assisting with more complex processes, AI agents like My Computer are paving the way for a more integrated, efficient digital workspace. Transforming workflow automation. Another leap in AI capabilities comes from AI, which has introduced the GLM-5 Turbo, a model specifically designed to handle long, complex chains of tasks and workflows. This move marks a departure from simple question-answering models, as GLM-5 Turbo is optimized for end-to-end process automation. With a context window of over 22,000 tokens, it can seamlessly manage workflows ranging from scheduling tasks to handling intricate processes in industries like healthcare, finance, and logistics. What truly sets GLM-5 Turbo apart is its focus on reliability rather than speed. While other models may prioritize quick responses, GLM-5 Turbo ensures a low error rate, only 0.67%, making it incredibly reliable for mission-critical applications. Its ability to reduce mistakes while processing large amounts of data gives it an edge in real-world scenarios where precision and accuracy are non-negotiable. Moreover, GLM-5 Turbo's pricing structure reflects its robustness, but it's not the most cost-effective option available. This points to a growing trend where businesses might face the dilemma of choosing between open-source, widely accessible models and premium, tailored solutions designed to optimize specific business workflows. As companies continue to evolve, GLM-5 Turbo's combination of reliability, efficiency, and scalability positions it as a game-changer for automation in high-stakes environments. Verifying code with AI. One of the more niche but crucial advancements comes from Mistral, which has introduced a model called Leanstral, designed to verify the correctness of code. While many AI systems can generate code, they often cannot guarantee that the code will work as intended, especially in critical systems like healthcare and finance. Leanstral works with a system called Lean4, which is used for formal proofs. This means the AI can mathematically verify that the code behaves as expected, ensuring it works without errors. What makes Leanstral impressive is that it can achieve this level of verification using a model with just 6 billion active parameters, making it both cost-effective and powerful. The race for the next big AI breakthrough. All these advancements highlight a key trend in the AI industry. The race to build the next big breakthrough is already underway. While the development of new AI architectures like Mamba promises to reduce the computational burden of long data processing, innovations like Leto, Inspio World FM, and My Computer are showing that AI's applications are expanding far beyond what we thought possible. As companies and research labs push the boundaries of AI's capabilities, we are witnessing a shift towards models that understand and interact with the world in new and exciting ways. From 3D object reconstruction to spatial intelligence and workflow automation, AI is increasingly becoming a tool that not only assists but takes action. That's it for today's look at the future of AI. If you found this interesting, make sure to like and subscribe for more cutting-edge updates.